So we're doing 12.1 today, and basically the only thing we're going to do in this video, and will be very quick, is we're going to start talking about three-dimensional objects. And before we can start talking about how to find volumes and surface areas of three-dimensional objects, we have to understand how to name them and what some of these terms mean, because it's going to make finding the volume and surface area much easier if we understand how to name these objects and what they mean and what some of these terms mean. So let's just get right to it. So we're going to read through this. A polyhedron is a solid that is bounded by polygons called faces. So a face of an object, here we have objects right here, and right here this is bound by polygons. In this case, rectangles or squares. So a face of an object is just what you see here. So think of a box, or think of maybe like a tissue box. The face is just one of the sides of that object. An edge is a line formed by the intersection of faces. So we're going to call that an edge is just simply going to be like one of these lines. Okay, and then the last thing, it says a vertex is a point where three or more edges meet. So the vertex is going to be like one of these corners. So we're going to call it the corner. So vertex is a corner. Okay? And then it says a prism is a polyhedron with rectangular sides and two parallel bases. What we see here, this is what we call a prism, because we have a top and we have a bottom. That's a good way to remember it, is a prism has a top and it has a bottom. Okay, and then a pyramid is a polyhedron with triangular sides and one base. So all pyramids will typically come up to a point. Okay? So it says to classify a prism or a pyramid, use the shape of the base. So here, because this is a rectangle or a square, we'll call it a rectangle for right now, this would be a rectangular prism. Over here, because this has 6 sides, that's a hexagon, this would be a hexagonal pyramid. Now, a couple of other things here just to give us definitions. So the base, right here, the base is what's on the bottom. And then what we call up here, the point, we call that the apex. So now what we want to talk about is, we're going to talk about this formula right here. F represents faces, V represents vertices, okay? And E represents edges. And vertices is the same thing as a vertex. So this is what the formula says. It says that the number of faces plus the number of vertices, or vertex, is going to be equal to edges plus 2. And we are going to use that. So make sure that we can identify these. We're going to run right into these problems here, and let's just answer these questions. It says, tell whether the solid is a polyhedron. If it is, classify the polyhedron and find the number of faces, vertices, and edges. Okay? So the first one, this is a polyhedron because it does have polygons as its bases. So yes, it is. And then we're going to name it. Because it is a rectangular base, we're going to call it a rectangular prism. Then it wants us to find the number of faces, vertices, and edges. So again, faces is just going to be the number of sides. So top and bottom, left and right, front and back. That's 6. Front, back, left, right, top, bottom, 6. And then we have vertices. Vertices is going to be the number of corners. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 vertices. And then edges is the number of lines, essentially. 1, 2, 3, 4, 5, 6, 7, 8. And then we still have 9, 10, 11, 12. So there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So make sure you're adding all those up correctly. Our second one, this is what we call a cylinder. A cylinder is not a polyhedron because it's not a polygon. There's no polygon involved with the circle. That's not considered a polygon. Okay, the last one is a polyhedron. And again, look at the base. So the base, because it's marked as such, it has 4 equal sides. So therefore it's a square. Always name it based on the base, square, and because it comes up to a single point, it's a pyramid. So it's a square pyramid. And again, we do faces, 1, 2, 3, 4, and then the base is 5. The number of vertices is 1, 2, 3, 4, 5. And then the number of edges, again, number of lines, 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. Okay? So what I want you to do is I want you to do this one over here on your own. Hit pause on the video, try it, make sure you can identify it and see where you get. So the big thing is I want you to identify the number of faces, vertices, and edges. If you want to try Euler's formula, go ahead, but we will go over that. Okay, so hit pause, hit play when you're ready. Okay, so what we have here is we have faces is 8, we have the vertices is 6, and we have the edges is 12. Okay, so that should be easy. Now, to verify with Euler's formula, what we're going to do is we're going to use this formula right here. F plus V equals E plus 2. So let's just plug these in. So that means we have 8 faces, we have 6 vertices, and that should be equal to 12 plus 2. And that is equal, 14 is equal to 14, so we're good. All right, again, do this one on your own. So we know the number of vertices, we know the number of edges, we're trying to find the number of faces. So use this formula up here to solve for that and hit play when you're ready. Okay, so we have F plus V equals E plus 2. You plug in the 12, the N, the 18, and then go through and solve, and you should have gotten that there is going to be 8 faces. So that wraps up what we're doing in section 1. So I will see you in class. Don't forget to take your Edmodo quiz if that has been assigned to you. Bring questions with you.